Ahmed, are you there, Mr. Ahmed? If you could just go through quickly, show our audience how they could install the Arduino on their computers, please. Are you there?
Yeah, I'm here, Doctor.
Okay, okay.
Thank you.
Yeah. So I will stop sharing.
Okay.
I think I need to stop sharing. Yeah. Where I have to stop sharing. Yeah. And you can take over now.
Okay. Good morning, everyone. I would like to welcome you all. I would be with you to show you how to install the software. I will share my screen. Okay. Do you see my screen? Okay. So we have two ways to download the software. One of them is directly from Microsoft Store. So we can download it there, and also it has automatic installation. Sorry. Okay. And the other way is to download from the website, as Dr. mentioned, arduino.cc, and we have to install it manually. So if we install it from Microsoft Store, we will just open Microsoft Store and type Arduino IDE in the search box. We see this logo, this app. So we click on it and it comes here. And all we have to do is just click on install. So it would download and install manually, automatically, sorry. And after that, you just have to click launch and the program opens, you can use it. And the other way is to download it from the website. We have to go to that link. I will show you the link in the meeting. Arduino.cc, and you can download according to your operating system. We have it for Windows, for Linux, for Mac, and for us, we have Windows, so we download for Windows, and it just after downloading, when we open, that comes on the screen, and you just click on next, and you click on install. It will install the program, and you can use it easily. That's all. If anyone has issue, you can share it with us. And we will share the link with you. Okay, that's all. Thanks.
Okay, so if you could stop sharing, yeah. I don't know. I'm sharing now. Do you see my?
Yeah,
yes, Doctor.
Yeah. Okay. Okay. Thank you very much, Mr. Ahmed, for your presentation, for showing us, how to share, how to install the Arduino. Okay. At any time, if any one of you, you got any problem, you can approach us through our emails or through the website. Through our website, you can approach us, and we are ready, to help, hopefully. Okay. So this is the front page of the Arduino, as Mr. Ahmed mentioned. So from here we have the drop-down menu. We can choose, we call it IDE. I think let me stick to my presentation is better. Okay. So as I said, the programming is done via C++, which is a high level and very widely used. Been, I don't know, for a few decades, the C language has been around, and I wouldn't imagine that there is any engineer who doesn't know how to use it, how to use the C or the C++. Okay, so, and I believe this is why, the Arduino people, they decided to, to use it as a main programming tool for the Arduinos. Because of its widespread use. Okay, as I said, it's been around for some time. Arduino is based in C++, okay? And I would like now, to start showing you some examples. But these examples, I'll be executing them on a simulator online in front of you. And at the same time, if you copy the code and do the connections, I will show you, how to do them. You could, if you have the Arduino Uno board, you could, by all means, you could get it running on your boards. Okay. The first thing is here is the blinking of an LED. The LED for those of us, with more, engineering mind, where yeah, the code for, excuse me, this is a diode, okay, and the LED, we usually, we put some arrows to show that they emit lights. So this is an LED. This side is called cathode. This is cathode, and this is the anode. When the current passes through from the anode to the cathode, it emits, it gives light. Okay, and we have them in many colors. The connection, we call this one here is a breadboard, and this is the Arduino. This is the Arduino Uno. If you can see here, it says Uno. Okay, so this is the Arduino Uno. And what we need, in order to limit the current, if you can see here, I have a resistance, okay, to limit the current. So we can put a resistance here, and this goes to the ground, which is the negative side of the battery. And this side here, this goes to the positive side. So if I have a battery here, I connect it this way, it will glow, okay? If I have a battery, so the current will be flowing through the battery in this way, okay? We have actually, I have this on the simulator, so I can get you to the simulator, I hope, from here, directly from here to the simulator. I just need to wait a little bit to have it loaded. Yeah, so this is the simulator. The simulator is called Tinkercad, okay? And Tinkercad is free. You can, join the register on the Tinkercad. Is free as long as you have a Gmail And I believe most of you, since you joined us on the Google Meet, so you do have uh, a Gmail, you know, so you could easily register and start using it. You know, it's very simple to use. Anyway, so I've already entered uh, this board, you know, exactly the same connection, and I will show you now how to use them and where the things are residing. Okay, so this is the code. So if I press here, this is the programming. Okay, and of course, not necessarily, you know, you can do actually projects without writing a single piece of line uh, on uh, on the computer. Okay, so you can have like pictorially with the blocks. Okay, so you can have it on blocks or as text. Okay, but since we are most of the people here are engineers, I think we like challenges. We like to write instructions, you know, rather than using blocks pictorial. Okay, but it is available here on this web page. And after we've done this, actually, you can copy. You know, you can copy this program and take it and paste it in the Arduino. So it's simple as that. You know, Control C, Control V. Okay, copy and paste. So the this is quite handy actually, and you can test your program, make sure the circuit is working, the program is working perfect, and then you take it to your Arduino, to the real life, to the hardware. Okay, and I believe from here as well, you can upload it directly to your Arduino board here. Okay, through the serial port. This is the serial port of the Arduino, and you know, is from the other side it will be connected here from the other side to your USB, and you can upload it directly. Yeah, whether from the simulator here or from the IDE of the Arduino. Okay, let me just talk a little bit about the Arduino board since we are here. This is the first exercise we are going to do. So if we look here, let me magnify it here. This is the Arduino board. So we can see here we have the pins. These are to be connected to the external world. You know, through these pins. So we have the I reference. I will skip this one for now. This is analog reference. Okay, so I will skip this one. This is the ground. This is the pins. You know, start from pin number 0 all the way to 13 on the Uno. Okay, there are other boards like Mega, like Dew. They are bigger and they have more input-output pins. Okay. As you can see here, there are some of them. They have this mark on them. These are actually special pins. We call them PWM pins. Uh, so these are special. I will through the program I will mention. You know, I'll explain to you. You know these. Okay. We call them pulse width modulation. Here we have the A. These are the analog pin. These are all digital, by the way. These are all digital, ones and zeros. One is 0 and sorry, one is 5 volt and 0 is 0 volt. Okay, because the device is 5 volt, as you can see here. This is 5 volt. Okay, and these are the analog pin. We can have analog input to our board. Okay, these are for inputs. And then we have these other pin, you know, these are the power, and we have some other, this is for interrupt and other things. Okay, for resetting. So we have a hardware reset. We can reset the board from here. It's a push button. If I press it, it will reset the board, and it will commence right from the beginning. So this is the board. What do I have here actually? As I said, it's just a simple LED circuit. So if I come here, you just over the pin, it will tell you. The simulator will tell you what pin it is. Okay. So as you can see here, this is the cathode, and the other one is the anode. This is where we usually connect the positive side, and this is the negative side. And from here, the breadboard, let me explain the breadboard as well. All these points in this row, from here all the way to here, they are all connected together, okay? And then same thing on the other side. From here up to here, they are connected together. And then the one next to them, they are all the same point, okay? But of course, this line, this column from this column are different, okay? And these ones, the same thing. We have here two rows. This is called minus, so we can connect like the ground here and the supply, the plus here. This is plus minus. And the same thing, we have them here as well, the plus and minus. And this whole row is connected together, okay? So as you can see here, I have a ground, and I don't need to take the ground from here, from this particular one. Why? Where's my cursor? My cursor. Okay. So this is the ground here, the black one, and I'm taking, oh, sorry. And I am taking it from here because this is same point, okay? So I have this point here is same point as here, okay? So I'm taking here and connected to this. This is oscilloscope. It will show me the signal, okay? We'll run it now and we have a look, okay? And this side goes to the LED and monitor what sort of signal the LED is having, okay? The other side, the cathode goes through this resistance and goes here through this black wire and get connected to the ground, okay? So that's the circuit. It's very simple circuit. And from the other side here, the red and black, I'm supplying to the board. This is called the breadboard. I'm supplying the breadboard with a plus and minus, okay, with the ground and 5 volt. Okay, to start the simulator, by the way, to make connections, let me just show you how we make connections. Like this point, I want to connect it to a point here, okay? So it's just as simple as this, you just, with the mouse, you click, and you made the connect. Sorry, it didn't connect. It's connected now, okay? So this point here, this whole row, or column rather, is connected to this column here, okay? And if I want to, I can change the color of this wire. This is supposed to be like a piece of wire, okay? So I can change it, okay? I can make it orange, okay? So it's orange now. Yeah. If I don't need it, what I do, I just click on it and delete. Okay. So I'm deleting it. Okay. The scope, yeah, like any of the component in the board, if I click on it, a dialog box will show up here. It's telling me, what's is 1 kilo. This is 1, and the unit is kilo. Okay. And this is unit number 1. We don't have any other unit. It's only just one resistor we're using. Same thing with the diode. So if I click on it, say this is LED number 1, and it's telling me, the color. I can change the color of it from here. It'll give me a list. Okay, what sort of light, what sort of illumination it will give. So if I don't like the yellow, I can change it. Yeah. And here, this is the oscilloscope. This is the dialog box for the oscilloscope as well. Is telling me this is, I don't know, for some reason, say this is device number 2. I think I had another one. I wanted to show here the resistance, but I deleted that. So probably this is why it's still having the same number as currently number 2. Anyway, and here it tells me, the divisions. This is the this is the name. Yeah, this is the time division. The oscilloscope here, you have the x-axis is the time division, and here this is the voltage divisions. Okay, so with here each division is 0.5 second each division. Okay, so let's run it and see what we have, what we get. Okay. Can you see here? I have the LED is off for two periods, okay? Which is, we said 0.5 times 2 is 1 second. So it's off for 1 second and on for 4. 1, 2, 3, 4, okay? 4 times 0.5, that's 2 seconds. So it's off for 1 second and on when it is high. This is high, and this one here is low. Okay, this is the 0 axis. Okay, 0 applied to the LED, it doesn't eliminate. Okay, and when we apply 1, it will give us the light. It will illuminate. Okay, and now what I can do, I can go and look at the codes. What sort of code I have here. Okay, let me see my program. This is my program. Okay, and I can magnify it so we can have a better view here. Okay, we start here. This is where why is not showing? Yeah, 1013. Yeah. I wonder why is anyway. Actually, this I think is doesn't show. Yeah, I thought it looks funny. Okay, the with C with Arduino, with C++ here, if we have slash double slash means the whatever comes after to the end of the line is a comment. So these two lines are comment lines. Okay, it will not be counted, by the compiler, by the system. Okay, and then the first instruction, okay, that the compiler will take or encounter, actually, it will be this here, line number 3. Okay, what I say here, int LED equal 13. Okay, and it ends with semicolon. So we have to have a semicolon at the end of each instruction. And then if I want to make a comment here, say, I can say, sorry, why it's not typing? Oh, I don't know. For some reason, my keyboard are not typing. Anyway, I think because I have the PowerPoint is running, probably. I don't know. It looks that I cannot type. My keyboard are disabled for some reason. Sorry.
Doctor, you need to stop simulating.
Oh, sorry.
To be able.
Yes. I forgot this one. Yeah. Thank you very much. Okay. Yeah. So now, what I can do, and then I can write a comment like I say, the LED is connected to pin number 13. Yeah. So this is a comment. Okay. 13, no, 22. Okay. Yeah. The other thing, it is object oriented programming, the C++. So you can have the same statement actually split over more than one line. So if I do it this way, yeah, this is still okay. The computer will recognize it that I'm saying init, okay, is integer. Int is short for integer. LED equal 13, so it doesn't have any problem. Okay. Yeah. And then we come down. So this section here, actually, it is for declaring variables. The first section, although we can declare them here. This is the other section. We have two voids. This is void number one, and this is the other void here. Okay. This void is for the setup. Okay. And what's before the setup void, we can call it, is somebody is knocking the door. Anyway, so before that, that's the variable declaration. So I'm declaring here that a variable called LED, okay, this value is 13, and it is an integer. There's no decimal point with here. There's no, like 13.5 or point, because it's a number, a pin number 13. So I don't need any decimal point. So this is why I defined it as integer. Int is short for integer. Okay. And here what I'm saying, I'm defining this pin. When we look at the pins of the board of the Arduino, we consider ourselves as if we are sitting inside the CPU. Okay, so we look at it at the outside world from inside the Arduino. Okay, so for me, since I'm looking from inside outward, so pin number 13 is actually an output. Okay, so since it is an output, I'm defining it. This is the pin mode. This is the keyword, by the way, PIN, and M starts with mode, M capital. Okay, this is a keyword for the Arduino. And I'm defining LED as an output. And if we look here, we see that output is all capital, okay? All capital letters. And then, I'm defining, I define the LED, which is pin number 13, as an output, okay? And then I'm going down here to the loop. This is a loop. You don't need to do any looping. For those people who does, programming, the Arduino is doing it internally for you, okay? So you just put here, so anything between these two curly brackets, this one here, and this one here is going to loop again and again, over and over again, without you needing doing anything to it, okay? This is something similar to the PLC. Those people who knows about the PLC, programmable logic controller. This is what the PLC does. You know, it will automatically, you know, when it's finished, the instruction, the ladder program, it will go back to the top and repeat again and again. So this is similar, okay? It's a microcontroller, yeah. So I have here the, what I'm saying here in this line here, I'm saying digital write, okay? This is a keyword as well, digital write. And I'm saying, you know, what to write. Write LED, which is pin number 13, or make it high. High is 5 volt, okay, high. And then I'm inserting a delay as saying, you know, keep a delay of 2000, and it is millisecond. So 2000 millisecond means 2 seconds, okay? And then what I do, I say delay, and then I write, but this time, same thing, but this time I'm turning the LED off, so I'm writing low, which is 0 volt, to the pin number 13, okay? And then I'm keeping a delay again, but this time I'm keeping a delay of 1000 millisecond, which is 1 second, okay? And so this is basically the program. And sorry, let me come down here. Yeah. So if I come back, we could change it. Let me do something. Let's change like this one here, the 1000. It stays off for 1000, which is 1 second. I'll make it 2 seconds, okay? So let's see what will happen here now. And if I go and say start simulation, and we bring, you can see here's the blinking, 1 second on, 1 second off, okay? You see, 1 second, this is 4, and we said each division is 0.5 seconds, so we have 4 divisions off and 4 divisions on, okay? So it is actually working as we've intended, okay? I don't know whether, what's the time? How much left? Okay, I think I need to speed up. There are 2 more examples, so I need to speed up. And I go back to my presentation here. These are the program actually, which I did, you know, in the earlier on the simulator, and we've all seen here. This is still, you know, say 1000. Where? Here, if you can see here, still says 1000. Yeah, this is still 1000. Yeah, we changed it. We made it 2000. Okay. Now we have another example here. I know these are very simple examples, really, but since it's fundamentals, so we try to keep it simple for the very beginners. Yeah. If we look here in this diagram here, I have what I have. I have LED and resistance. Okay, same connection as the previous one. This part here, this part actually the same connection as the previous one. Okay, but here I'm controlling it through the programming, through the program. By the way, in Arduino, they don't call it program, they call it sketches, okay? So through the sketch, what I'm doing, I'm having a push button here, okay? and the push button, when it's depressed, it will change over the condition of the LED. Okay, so I'm controlling the LED. Of course, we say LED here just because for simplicity, but actually it could be a machine, it could be any device. Okay, could be a massive machine, but we need to do the proper electronic drivers, for from the Arduino to the machine, and it will work. Okay, so whether it's LED, simple LED, or a big machine, the effect will be the same as long as we have the proper driving electronics between the board, with the Arduino board and the machine we are controlling. Okay, so let me click here on the link. Why it's not? Oh, probably I need to. Yeah. And so it's opening again the simulator with this particular example. Okay, so now I have the example. Okay, let me run it quickly for you, and we see how we can control this LED. Okay, we can see I'm actually measuring, this is the voltage. I'm just measuring the voltage across the diode, across the diode, how much voltage, or between together the diode with the resistance. Okay, and if I press here, I just bring my mouse and click on it. Okay, you see, as long as it's depressed, I'm keeping it depressed. Okay, as you can see here, the LED is on, and what we can see as well, we can see the voltage, the voltmeter. My voltmeter is reading 4.47. Supposed to read 5, but because there are some drops, the is simulating the real circuit, because of the drop. So the 5 volt doesn't stay 5 volt. Okay, there is a loading on the power supply, so it drops down by a few millivolts. Okay, so as long as so if I just single click, just a quick click, and look, the LED flashes. Yeah, the LED flashes, and the meter can pick up this. Okay, yeah. And okay, let me just do a little explanation about this resistance, this other resistance, and what we call it. This is called pull down resistance. Let me, by the way, since we are here, let me change the color of this one, because this is supposed to be connected to the ground. So let's have black. Okay, so I can change the color of that and became black. Okay, so I can change the color of any. So we try to keep the color coding right. Okay, the ground is supposed to be black. The high voltage, or the 5 volt, or whatever the supply is, we keep it. The convention is red for it, as here. So here this is red, and so on. Anyway, let's look into the coding as well. This is the coding, and let me zoom into it. Yeah, here. Okay. With this code, we have actually, again, the same thing. I have the declaration, but here I've declared 2 variables. I declared the LED, and here we declared the push button. Okay, push button. And push button is pin number 2, and the LED is 13. So I want you to imagine which one will be the input, which one is the output. Here, I have two pins. One of them is input, the other one is output. Number 13, let me quickly go back to the number 13. So here, if you look at this one, where is connected to? Connected to this circuit here, connected to the LED. Whereas number 2, pin number 2 here, this one, is connected to the switch, okay? This is the switch circuit. And we said this point is same as this point, okay? So it's connected here. And the other side of it, from here, is connected to the ground, this is switch. By the way, these 2 points of the switch, this one and this one, the same, okay? And same thing, these 2 are the same, okay? And this side is connected to the positive here. You can see this one is connected to, let me change the color of this one as well while we are at it, okay? So, okay. So, yeah. So if we go back to our program, to the sketch, this is a sketch, okay? And we have the 2, as we said, we have 13, okay? And we have number 2. And here I'm defining something else. It's called serial. This is the serial port, okay? Which is the USB port. So the Arduino, as long as it's connected to the computer, it will send something to the computer, okay? And we will see now what is sending to the computer, okay? We'll have a look at now. Let me reduce it and start the simulation. Okay, let me. Okay. Anyway, okay, I think should be from the side. I should be able to change it from the side. I want to raise it up. Yeah.
Can you give me the schedule? Can I take that picture?
Okay. It's the serial monitor. I don't know why it's not. Yeah, it's showing now. Sorry. Yeah, you can see it's sending 0. Sending zeros, 0 after 0, a line, just 0. And let's see what will happen if I, I have to stop it to do something. Okay. Okay. So now, if I start again, and if I press, did you see what happened? I want you to look at the serial monitor. Now it's sending ones because I'm pressing, so I'm asking to turn the light on, okay? The switch is giving giving 1 to the board. It's sending 1 to the Arduino to pin number 2, okay? And if I lift my hand, look, I'm lifting, I'm clicking and lifting, okay, my hand. And look at the voltage as well here. The voltage on the voltmeter is changing at the same time, okay? So it's changing from 1 to 0, okay, through the key, okay? Of course, in the real life, if you press here, this is a switch, you know, you have them, by the way, available, and they are very cheap. Okay. If you press on this switch, the same thing will happen. Okay. So this is a very good simulator, really, for the beginners. I really advise you to use it. Okay, let me go to the, what's the time now? Yeah, I have to leave some time for the questions and answers as well, yeah, or for comments. Let me go back to my my presentation, yeah. So this is the push button. This is the sketch for the push button. It will be available on the web page, or if you want, we can send them regardless whether you ask for them or not. We can send them, or I would rather, you know, you download them from the web page. Okay, I think it's better. It's better that way. Okay, this is the last one. This is the last exercise we're doing today. It's called the traffic light. Okay, so the traffic light, we have 3 LEDs. We are emulating the traffic light. Okay, so we have the green, yellow, and the red. Okay, with each one, we have a limiter resistance here. This is a resistance, and they are one side of them. You know, the cathode of them is connected to the ground, as you can see here. It's connected to the ground. And the other side is connected to 3 different pins. Okay, they are connected through to 3 different pins. Let us not waste much time and go straight to the simulator. Okay. Yeah. Okay. This is the simulator. Okay. Let me magnify it. Okay. Okay. Let's start and see what's happening. Okay. Start. I want you to look at the LEDs here. The green one is on. Then the yellow one. Then the red. Okay. Of course, there is no traffic light, you know, works at this speed. Okay. Usually, each one stays on for, I don't know, a minute and a half, 2 minutes, you know. And then through the transition, through the amber or the yellow, it changes over, yeah, to the other one. Okay, so this is, let's look at the sketch. This is the sketch, okay, and here, what we have 3 variables, okay, 3 pins. We use the 3 pins, yeah. So we have pin number 8 and 12 and 13. These are our pins that we use them here. And then, so this is the declaration of variables here in this section. And then we come here, what we do actually. Yeah, let me bring it closer. Okay. Yeah. And here in the void loop, you know, we have a for statement. This is a loop, okay? Loop statement. Okay, so it's got a condition, it's integer I equals 0, okay, to 10, okay, and then increases I equal I plus 1, okay, so I increases by 1, okay, and so it will loop here, okay, and then it sets itself, so if it stays on for a short period of time, sorry, the green one stays on, and then when this predefined time is reached, it will change over to yellow, and then after that, it will change to red, okay? And if we look here, we'll find that this is the 8. 8 is the pin that corresponds to the yellow, sorry, to the green here. This is the green, actually. And this is why I advise you, when you write things, to try to make them, meaningful. So instead of just saying 8, pin 8, pin 12, and pin 13, give them meaningful name, like, we call them green, yellow, or amber, and red. Okay, so it would be better, meaningful. So when you go through the program, especially for the debugging, or if you revisit your program after a while, you know what you're doing. You don't need to spend too much time to uh, to open the codes. You know why what you've done here and what you've done there. Okay, and why these are so. Okay, I think there is about 15 minutes left, and I better leave it for your comments, okay? And so I will terminate here. By all means, if you have something, tomorrow we are going to meet, hopefully again. If you have anything, any concerns or any doubts about something, you can raise them tomorrow. Though I'll be among the audience, but I'll be available. Okay, and perhaps if not me, Dr. Priyanka, she can help as well. Thank you very much for your sorry, and let me just go to my presentation and try to finish here. This is the end. Okay. Yeah. Uh, Mr. Siva. Yeah. 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 I don't know if there are any. Thank you. Yeah. 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 And UK. And for UK, for the people who joined us from UK, Doctor, it's 7 o'clock morning. I know it's a bit early for them, but we have people that joined us from there, yeah, as well. Yeah. Okay. Thank you. Yeah. Thank you very much. Yeah. Yeah. Okay. So, yeah, I don't know if Dr. Khalid is with us or not. I don't know if you want to say something.
Thank you. Hello everyone. I think it was a good presentation. Thanks to Dr. Ezideen for this very detailed and very good presentation. It was so clear to me. I'm a computer scientist, but I believe that everyone can understand this simple presentation, and it was very connected to real basement infrastructure, or building structure of Arduino and coding. C++ is another story. Everybody should study coding in some way. C++ is one way, and Arduino is using this strong language. Thank you, everyone. Thank you. It's very good. I believe that it is beneficial to everyone.
Okay. Thank you, Doctor. Thank you very much. Okay. Yeah. And I would like to thank everyone who participated today and joined us, from more than, I don't know, 2, 3 countries, or probably 4. I cannot see, probably we have some people from North Africa as well, joining us today. Anyway, thanks again. And so I look forward to see you again tomorrow, hopefully. Okay. And as for the people who joined us, I don't know, probably from all over the world, wherever they're from, but especially in India, the situation with COVID is very bad. So I wish you guys, all of you, to be, in good health and protected, and look after yourselves and your families as well. And thank you very much for joining us. And Dr. Priyanka as well, I thank her very much, for her effort as well. Okay. Yeah. Thanks again. And from my side, I think unless somebody wants to say something from my side, I've finished. I'm done. And thank you.
Excuse me, doctor. I want to add one more information. Thank you
Yeah.
for your beneficial presentation. It was clear and beneficial. Here you used Tinkercad as a stage to apply. It's an online stage. They can also use their own program. They can download. It's offline. They can download the Proteus and download the package of Arduino and do the same thing, but it will be on their computer. They will not need for internet, and they can save their programs in their computers.
Yeah.
Yes.
Yeah. Thank you for
you.
mentioning. Yeah. Thank you for mentioning this, Sid. Thank you. I don't know if do we have Dr. Mohammed Saeed, Professor Mohammed Saeed from Leeds University from UK. Dr. Dr. Mohammed Saeed Saleh. Is he available with us? If you want to say something. Yeah, earlier on I saw him. On yeah, but anyway, probably he left. I don't know. Anyway, yeah, from my side, I'm done. Thanks. Okay. Yeah. Thank you. Okay. Bye bye, everyone. Bye.
Thank you, sir.
Thank you, everyone. Thank you. Thank you.
you.